start by kind of recapping all this transformation stuff that we've been talking about this week. So, given some function, let's call it f of x, the things that we've been looking at break into, three basic types. Shifts, or those are also called translations, which are basically, like picking the graph up and moving it around. Taking a point from its current location and moving it to a different spot. So if we have some kind of, and thinking about these parent functions talking about, if we take some kind of distinctive, visually, representative point that we can keep track of, a translation or a shift is like, okay, well, this point used to be at 0, 0, now it's over. To get there, you had to move it and down, right? Something like that. What causes those to happen? Like, what do you have to do to the function to, pick it up and move it like that? Add or subtract. Add or subtract the amount we want to shift by on the inside or the outside of the function, right? Adding or subtracting to the inside moves to the left or right, to the outside for up or down. Like, that's the operation that makes that happen. You can think of it a bunch of different ways. If we're adding something to the outside, it's like we're increasing the y values directly by whatever that amount is, right? So if I take the function and I add 2, okay, well, now all the y values are 2 bigger than they were. They sit up 2 higher than they used to. That has the appearance then of picking the graph up and lighting it up. Stretching or shrinking or compressing the graph, that's changing the shape. Not in the sense of it's going to look totally different, but it's going to take this thing and cause it to be either sort of more narrow or wider. You can also think of that as like taller or opposite of taller. Thank you. Shorter is a good word for that. I had a moment there. Something like that, right? Kind of affecting the shape. That comes from multiplying, because I've started putting bubbles around these, so I got to stick with it now. Multiplying by a scalar, which is just a number. But it's called a scalar because what it does is scale the thing, so it changes, right? Just, sort of like if you, like a window, stretch it one direction. Again, inside we think of as sort of affecting the horizontal, outside is affecting like the vertical, and then the size of that number determines whether it's stretching the graph or compressing. If I take a function and multiply out in front of the whole thing by 2, well, it's going to be twice as tall as it used to be, so it's going to look narrower, taller, faster, something like that. If I multiply by half instead, it's going to compress the whole thing down and kind of make it sort of lay out. And oh, I've run out of room. Flexions. flip or reflect or mirror over one of the coordinate axes. A negative sign or a negative factor does that. Outside would flip the thing upside down, so over the x-axis. Inside would flip it left or right, or over the y-axis. So taking, where there was an x before, replacing it with negative x, or negative out in front of the function as a whole. Okay, and then the other thing that we have to keep in mind is that order is important. And I'll just kind of write that off to the side here. Order matters. Sometimes it turns out that the order doesn't really matter, but often it does, and we want to treat it like it does all the time. So the general idea is that if we've got a representation of a function that we're trying to figure out what it does, we kind of want to work from the inside out and follow like order of operations in deciding what these things do and how they work. So here, if it'll let me scroll, here's an example. This is 8 from the notes. Describe and sketch y equals the negative square root of x minus 1 plus 2. Okay, what kind of function is it? Square root. What does the square root function look like? Thank you, Carly. Like that. That's before I do anything else to it. Now, what about this changes that? Or how does it change it? Okay. Start on the inside. So right there. Again, the idea is if I gave you an x value to plug in, what would you do? Like what order would you apply these different, operations and things to it? The very first thing would be that minus 1. That shifts to the right 1. See if I can actually do this live. Okay, they're shifting to the right 1. Then what? So if we're thinking through, again, sort of plugging in and evaluating, take your x value, subtract 1, then do the square root. So that's determining the shape, right? It goes q. What happens next? The square root counts like an exponent. Right? It's like a power, basically. So parentheses first, we did the inside thing, then we did the exponent, then this multiplication. Right, this negative sign out in front, really that's times negative 1. So the multiplication happens next. So we reflect over the x-axis, which again means it's going to look upside down, right? Now we have a thing that looks like that. And then the only thing left would be the plus 2. What does that plus 2 at the end or on the outside do? Shift up 2. Which would look something like that. Oh no. Something along those lines. Again, a sketch, I'm, probably not grading a sketch on like a test question or whatever. I'm not going to make you draw a thing. I'm more likely to give you a graph and ask you to tell me about it. Because drawing things makes people uncomfortable, and sometimes it can be kind of hard to grade too. Some of y'all write really like faintly, right? It's like, they mean for this to be there, or what's happening? So, probably not gonna, grade a drawing or a sketch, but that's what that would look like. Okay? Feel good about that? Does anybody have any questions about anything at this point? Okay, cool. Well, I have pretty much said my piece about graph transformations. In the note packet for this week, there are 1, 2, 3, 11 problems that we haven't, officially gotten to yet. We've got about 35 minutes left. So we're going to spend those working stuff. We'll talk about things as they come up. So please feel free to ask questions. I will come and, eavesdrop and hover and stuff. And check in on y'all, but work together. If you're not sitting with somebody, move so you have somebody to work with. And we'll talk about some things all together toward the end. Find yourself having misplaced your note packet. I did make a few extra copies of this last page